So good afternoon, everyone. Welcome to eighth session of the course on programming for problem solving laboratory. So in today's session, we shall be dealing with the 2D arrays and implementation of 2D arrays. So let me start it. I hope my screen is visible to all of you. Okay, so is this 2D array is covered in the theory class? Someone?
No, sir. Fine, sir.
Okay, fine. So I think the problems are shared. So you can see in the chat box that these are the three good assignments uh, based on 2D array. The first assignment is write a C program to multiply two matrices and then find the transpose of that resultant matrix. Okay, the product matrix. So you may try with several options. You may try this program with without any pointer. You may try this problem with by using a simple integer pointer. Okay, or you can use array pointer to solve this problem. Also, you can use array of pointers to solve this problem. So, why this assignment problem is given like this? Because we cannot finish, our implementation, the assignment one, using all the four options. Without it requires some practice, and it is not possible to finish in a single session until unless you are prepared with the algorithm and the concept of all such four type of options. Okay. So we will focus today based on option A and without pointer, and option B integer pointer as much as possible. Okay. So matrices. So before coming to this assignment, let us understand how can we create a matrix in using a two-dimensional array. Okay. Let's say we want to. So we want to create a matrix. Let's say a matrix of order. Let's say a square matrix or any rectangular matrix. Any matrix. Let's say any matrix A is let's say 1, 2, 3, 0, 1, 0, 1, 0, 1. Suppose this is a matrix, okay, A, okay, and we want to create it, and we want to see whether we are able to create such a matrix, and whether we can store this matrix into some in some memory. So can I store such a matrix in a memory, and can I access elements of this matrix? How to access all these elements? How can I play with this location, this element 1? If I want to make it 2, how can I replace it by a new value 2? If I want to add some value with it, how can I do that? So manipulating the matrix element, how can we do that? So first we need to understand how can we create such a 2D matrix on our own and store it into some memory, okay, and using the 2D array, of course. And then how can we display it? How can we visualize it? Okay, this is my matrix which I have stored. I need to see it, okay, and then I may have to manipulate it. Some addition, adding some value with a specific element, or adding a particular value. In matrix, you have several standard matrix operations. For example, let's say I want to add a scalar value with a matrix capital A, right? So what will happen? It will be added to all the matrix elements, right? That is a matrix property. So it will be A plus 1, then A, then 1 plus A, and then here A plus 1, and then here 2 plus A, and then here A plus 0, and so on and so on. So we can have a scalar addition operation on a matrix. Okay, so several operations we can perform on a matrix. How can we do that? So we need to do that, right? So in a very single line, we can create a 2D matrix. It's a static memory allocation based matrix creation. For example, let's say matrix 1. Okay, A matrix. A. Let's say we want to specify the dimension. If it is its dimension of this matrix is 3 cross 3. There are 3 number of rows and 3 columns. Okay, so 3 cross 3. So number of rows is 3, number of columns is 4. Right. So the first, in this way we can do that. Very simple syntax to create a 2D matrix. We know that matrices are 2-dimensional, but we can also, in higher studies, we may have a matrix of higher dimensions. Okay, so create a 2D matrix, or simply a matrix of dimension 3 by 3. So using this simple syntax, we can do it. So it is doing the memory allocation. It is doing memory allocation. What does that mean? It is doing memory allocation. Means by this, in memory, what is happening? This is just for your easy understanding. I am showing you. Okay, so here it is 1. Not all the values are there. So by that single line, what has happened? The name of this memory chunk is A. That is the name. And it's a 2D array. The name of the 2D array. Okay. And what will happen? It's of dimension 3 cross 3. Means there will be 3 rows and 3 columns. And there are 9 locations. Okay. So here you can say that there are 9 locations. Okay, 9 locations. 1, 2, 3, 4. Okay. And each of this location is capable of storing a single data. What kind of a data? That depends on the data type you have mentioned over here, int. Okay, so each of this location is capable of storing a single integer data. And each of those are smallest memory. I mean small memory locations. These are all memory locations. There are 9 memory locations. These are 9 memory locations. And altogether it forms a 2-dimensional array structure. Okay, data structure. So, and as these are nothing but memory locations, they will have their own memory addresses. So this location will have its own memory address. This location will have its own memory address. So all the 9 memory locations will have their own 9 different memory addresses. And there is a pattern in that addresses, and that is these addresses are contiguous. Why? Because we have used a 2-dimensional array. And in array we know that locations of the elements have contiguous memory addresses. Okay, so for example, if we consider that size of int data type is equal to, let's say, 2, then suppose address of this location is 1002, then address of this location will be 1002 plus 2, that is 4. Similarly, this one will be 1006, then this one will be 1008 and so on. So these addresses, memory addresses, are in contiguous manner, and that is the pattern in case of array, whether it will one-dimensional array or 2D or 3D array and so on, higher dimensional array. Okay, now we need to visualize this. Here some elements will be stored, and these locations are nothing but some memory locations. They will have their own memory addresses. So let's try to visualize at least this much in terms of programming. So I need to display all the arrays, addresses of such 9 locations, correct? The format specified to display address is %u, correct? Okay, so what is this? $a00. That we need to. So A00 means A00 means this location. This location is accessed by the syntax A00. So A00 gives us the value at that location. A00 gives us the value stored at 0,0 location or position. Okay, so this is the 0,0 location. This is 0,1, correct? This is 0,1. Its coordinate is 0,1 because the row index is 0, the column index is 1. So this is column index 0, column index 1, column index 2. This is row index 0. This is row index 1, row index 2. Row means this side along this. This is row index 0. This row corresponds to row index 1. This row, entire row, corresponds to row index 2. Similarly, this column, this vertical column corresponds to column index 0. This vertical column corresponds to column index 1. This corresponds to column index 2. So 0,1 means the row index 0 and column index 1. That means this location, 0,1. Okay, and how to, okay, so if I ask you, okay, how to access, let's say 2,1 location, can you tell me how can I access the value stored at 2,1 location? How can I access the value? What is the syntax to get the value stored at 2,1th location? Anyone tell me? Hello? Hello?
So with the help of array A2 and 1.
Oh yes, meeting is. I thought I am disconnected. Yes, hello.
So we can access it through the help of the array, which is the capital A2, A2 and then 1 in third bracket.
Yes, that is the syntax. So this gives us the value stored at this location, 2,1. That means this location. Okay. Okay. So if I want to access any location, ij, that means in general we are thinking that is the row index I, column index j. Then how to access the value stored at I, jth location? That will be, bolo ki hobe?
A of ij.
A, I, j. Okay. So what is I here for this example? I can be any value 1. I can be any value 0 or 1 or 2. So it can start with 0. It can end up with 2. Similarly, j can be any value. Some latency problem due to the internet. So 0, 1, 2. Okay. So I, j. to both of them. So one specific value of I and one specific value of j will give you a value at some one specific location. And if you want to access all the locations, all the 9 locations, then what? You have to apply some loop where I have to I have to be varied from 0 to 2, and also j has to be varied from 0 to 2. Correct? So what we are doing now, so let me show you the address of this. Okay, I do. So this is the value. Now, address of A00. This is address of operator, correct? Address of a variable. So this gives us very problematic address of A00. So this should give us the address of 0, 0th location, correct? So let's try to display that. Yeah, what you get? 2293,280. That is the address of the 00 location. Now I can change over here and see what is the location of the next cell, next memory cell, means this one. Okay. Okay. I have not compiled it. Now see 84. Earlier it was 280. Now it is 84. Though it may change from in runtime, but in this compiler, this C++, it is actually memorizing the previous. I mean, it is not doing that. It is not changing the memory allocation. Every time you run it, it is supposed to change the allocation of the memory, but here it is not changing. So that's why we are able to, discuss. Okay, 00th location is 280, 01th location is 284. So we can expect the size of int is in my computer is 4 byte. So if it is 280, it is 284, it will be 288. So just expecting that memory allocation will not change, I should get the answer as 288. Here it is coming 288. Okay. So every time what you are doing, so keeping the row index 0, I have changed the column index 0, 1 and 2. And what I get address of this one when j equal to 0, address of this when j equal to 1, address of this when j equal to 2, keeping row index equal to 0, correct? I have not changed the row index, that is the first index. I am only changing the second index, that is the column index, that is the j. The first index is I, correct? So what we are doing here, that is, so if you want to access the entire element, entire 0th row, this is the 0th row, then what we are doing here, the row index I is equal to 0, and then you vary. Oh. Yeah, you keep it fixed I equal to 0, and then vary j from 1 to 2. Initially 0, then 1, then 2. What you are doing for when it is j equal to 0, you are getting access to this. When j equal to 1, you are getting access to this, right? When you are j equal to 2, you are getting address of this location, right? Similarly, now you go to the next row. Okay, let's do this. It's a repetitive thing. So now what I want to see location of all these 3 locations, addresses of all these 3 locations at a time. As of now, I am just changing the code. I am able to see address of this. Then again run it to get the address of this. No. I want at a time address of all these elements. So I need a loop where I will keep I equal to 0 as fixed, and I will change j equal to 0 to j equal to 2. So this should be used as a for in the for loop. Let me do that. So for j equal to 0, j less than equal to 2, and then j plus plus 0 to 2, both 0 and 2 included. And here I want to display this printf, right? and here I will change the second index j. What is happening? I am keeping the row index 0, that means 0th row, but I am changing the column index j initially from 0 to finally 2. So 0, 1, 2. It will change from 0, 1, 2. This for loop will run 3 times, for j equal to 0, for j equal to 1, and for j equal to 2. And each iteration, it is actually displaying the address of this one first, then this one, and then this one. I hope all of you have understood as of now. So now I am making I equal to 0 as fixed. So try to understand, okay? Don't skip anything. This is very, very fundamental. I have to declare it as int. Okay, I got just logged out. I hope using two for loops. Yes, I am coming shortly. Okay, I'm not hurrying. Compile, int j, compile, now run. See, oh, just let me give some spaces. /t. /t is for a tab. I mean, some set of spaces. /t. It's an okay. It's an escape sequence. /t is an escape sequence. So here you can see this is the address of the 0, 0, address of 0, 1, address of 0, 2. That means what? This memory allocation is done. It has successfully created a blank 2D array. Also, it has done the memory allocation for each of this location. And now, what we can do? So this is doing a simple only a particular row. Now I want the entire 3 rows. How can I do that? Just include this entire block inside a for. So and I equal to 0, and then I less than equal to 2, and then I plus plus. So here I am changing the I, and inside it I will keep that for. Okay, no longer need this. So this is actually the row controller. It is controlling the row, which row will be displayed, and this is controlling the column controller. Okay, that means which column you are currently considering. Okay, so now if I display it here, I need to replace it the first index by I. Okay, let me for better representation. Okay, let me show you everything I am showing. See, this is the first row. The first 3 addresses are the addresses of the first row. I mean 0th row. Sorry, 0th row. And then next 3 addresses are addresses of first row. And this is the addresses of locations are in the second row. But if you need to visualize them in a matrix format, it is shown in a 1D. It is looking like a 1D. So where is the 2D? Okay. So let me help you to visualize in the format of a matrix. The printf, just put a /n. After every row, okay, you put a /n. That means new line. It will orient it into matrix format. Here it is. So after 3 addresses, that means 1 row is completed. Then you go to the new line. That's what I am doing, just for visualization purpose. Okay. So these are the addresses. So how can you access the addresses? Now you can display the contents. If I remove the address of operator, it will give me the values at ith location. So let's check what are the values. I have not stored anything. It's a blank array. And see, some garbage values are showing. Already are stored in those locations. In the previous output, you have seen the addresses of some memory locations. Those memory locations which is being used to store your 2D array, your matrix, capital A. Okay, but already in those memory locations, some garbage values are stored. You can see over there. Now we want to store some our defined values. Okay, we want to store on our own some values into that matrix. Okay, so how can I do that? Let's copy it. I'm accessing any ijth location and putting there and storing there some value. Let's say I'm storing I plus j. Let's say, for example, what should I expect? What I'm storing, I plus j means I'm actually and then storing over here. So here it is 0 plus 0. So it will be 0, 0 plus 1, 1, 0 plus 2, that is 2. And it will be a symmetric matrix. It will be 1, it will be here how much? 1 plus 1, 2. And here it is 2 plus 1, 3. And here it is 2, 2 plus 0, here 2 plus 1, 3, and here it is 2 plus 2, 4. So it's a symmetrical matrix. So I should expect, so I'm actually storing these values into that matrix. Okay, let me compile it. No error, but you can't see. You are seeing the garbage values which were initially stored into matrix A, but then after this I have changed. I have stored some values into the matrix on my own. That is I plus j. That means this should be the matrix. Now I need to see whether this matrix have these are stored correctly or not in my matrix. Okay, so let me. So I have to display that. So you have to display the contents of the matrix. Please try to ask any question, any sort of question. Maybe I am hurrying up and probably I am missing something. So please ask me questions. Okay. এখানে আমরা কি করছি? ডিসপ্লে করে দিলাম। পার্সেন্টাইল ইউ না করে ডি করে দিলাম। ঠিক আছে? দ্যাটস ইট। তাহলে প্রথমে আমরা দেখে নিলাম যে কোনো গ্যার্বেজ ভ্যালুতে কি স্টোর হয়ে আছে আমরা দেখে নিলাম। Initially we have not stored anything inside the matrix. Just created a blank 2D matrix, and we have seen that there are some garbage values already stored in those locations, right? And then on our own we have intentionally stored some values, let's say I plus j, and then we are trying to visualize, okay, actually those values are correctly stored in those places or not. Okay, so let me compile and run. Right, see, so this is the output of the matrix. These are the matrix elements before storing anything. Okay, just you have done memory allocation, just created a 2D matrix, blank 2D matrix. And blank 2D matrix means those are nothing but some memory locations, contiguous memory locations. And it may happen that some garbage values are already stored over there. So that is the output. And then intentionally I have stored some value into my matrix, in my matrix. And I am now seeing what I have stored in my 2D matrix. So these are the matrix elements which I have stored in my matrix A. So is it okay to all of you?
Yes, sir.
Okay.
Yes, sir.
So we can ঠিক আছে, তো এটা মোটামুটি now provide to store some values into the matrix, right? So user given values to be stored in a matrix. করছি না, এটাকে কপি করে আরেকটা প্রোগ্রাম একটা নতুন ফাইল। ওকে, এটা তো থাকছে। এখানে আমি কি স্টোর করব? So here I will ask the user. Here I will ask the user. User will provide element by element value, and it will be stored using scanf to a corresponding location. Okay. So printf /n enter a value to be 3x3 matrix. So I will ask the user 9 times, and so 9 times user will provide me a value. This printf message will be displayed for 9 times. User will provide 9 values. All those 9 values will be stored into 9 locations of this matrix A. Correct? So scanf %d ampersand ij. Scanf needs the address of the location where user given value to be stored is going to be stored, right? So whatever the value of is provided by the user, that should be stored in some I comma j location. And how to get the address of that I comma j location? This syntax ampersand aij. So I'm providing that to the scanf function. Okay, so this is no more required here. Enter a value. Or let's say what is this? 0, 1, 2, 1. Okay. The first is 0, then 1. So how will you provide these values? So due to the for row, I will store one row first, then I will go to the next row. Okay, that means first this value is being asked, then this value is being asked along this. Okay, are you getting my point? Along this, not this 0, then 1, then 2, not like this.
Yes, sir.
Okay, that is very crucial. Okay, that is very crucial. So first you are asking for this value, then you are moving to this location and asking for that value, and then you are moving to this location and asking for that value. After that, what? You come to this location 1008 and you are asking the user for this value. Then you go to this location and then you go to this location. So first 0th row to be completed, then you will go to the first row and complete it. Then you go to the second row and complete it, and so on and so forth, right? That is the thing. So 0, 1, 2, then 1, then I think it's 3, no, 2 go back, 2, and then 3, and then 2, then 3, then 4. That's it. Now we can see these are the user given values, 9 values, which are stored into these 9 locations. In which manner? First value given by user is stored here, then next value is stored here, then next value is stored here along this. Then this, then this. In this manner, user given values are one by one stored. And see, what is this output? This is simply displaying the values of the matrix A. What is present, what is stored into the matrix A. So if this is not done correctly, I know ki ami to I plus j টাকে মুছে দিয়েছি। দেখো কোডের মধ্যে I plus j আগের কোডটা কিন্তু নেই। আগে আমি ইন্টেনশনালি I plus j স্টোর করেছিলাম। সেই I plus j ভ্যালুগুলো এখানে ডিসপ্লে হয়েছে। এখন তো সেই কোডটা নেই। এখন ইউজার ইজ প্রোভাইডিং ভ্যালুস and storing into the matrix A, right? তো সেটা যদি ভুলভাল হতো, ইউজার গিভেন ভ্যালুস গুলো যদি একটা ম্যাট্রিক্সের মেমরি অ্যালোকেশন গুলোতে লোকেশনস গুলোতে যদি ঠিকঠাক স্টোর না হতো, তাহলে এইখানে ডিসপ্লেটা কি ঠিকঠাক হতো? ডিসপ্লেটা ঠিকঠাক হতো। তাহলে এই ডিসপ্লেটা জাস্টিফাই করে দিচ্ছে যে ইউজার যে ভ্যালুগুলো প্রোভাইড করেছে সেগুলো যে যার জায়গায় অ্যাপ্রোপ্রিয়েট জায়গায় লোকেশনে ঠিকঠাকভাবে স্টোর হয়েছে, সেই জন্য এই আউটপুটটা শো হচ্ছে। আদারওয়াইজ, so this is the justification. Okay, everything is going fine as per our theory, as per our understanding. বুঝা গেল? তো এটা গেল একটা ম্যাট্রিক্সে। এবার আমরা কি করব? আরেকটা ম্যাট্রিক্স স্টোর করব। ম্যাট্রিক্স যদি মাল্টিপ্লাই করতে হয়, you need two matrices, matrix 1, matrix 2. Let's say A matrix and B matrix. So we have done A matrix. Now same thing we will copy paste and do. এখানে করে দিলাম। So এখানে কমেন্ট দিদি বোঝা যাবে না, প্রোগ্রামটা বড় হয়ে যাবে। So here you need to let's say B 3 cross 3. So for simplicity, as we are beginner, so we are taking up two square matrices which are of same dimensions, 3 cross 3 and 3 cross 3. But you know, matrix multiplication to be generalized, it can be applicable to any two matrices provided they are satisfying the multiplication criteria. That is, whatever be the dimensions of the A and B are, they have to satisfy that the number of columns in the first matrix should be equal to the number of rows in the second matrix. That should be satisfied. Otherwise, those two matrices are non-multiplicative. Okay. So also that thing you have to implement when you go for the generalization. But as of now, we want to start from the very simplest situation. Okay. So P33. So here read matrix A, display matrix A. Here read matrix B. Here read matrix display matrix. Okay, only we have to change the name. See how much this is effortless. Okay. So let's say same matrix A we are providing 1, then 2, then 1, then I guess 2, then 3, then 2, then 3, and then 4. This is the first matrix displayed. And B matrix, let's say we want to okay, B matrix can be, let's take a B matrix which is a identity matrix I3. Okay, what is I3? Identity matrix I3 মানে কি কে বলবে?
1 0 0 তারপর 0 1 0 তারপর 0 0
elements
1
are 1, others are 0.
0. Yes.
3 cross 3. Okay, so let's take that. So 1 0 0. This is 0th element of next row. So this is 0. This is 1,1 location. This is 1,2th location. This is 2,0th location. This is 2,1th location. Now finally 2,2th location. Okay, so 1. Here it is, the B matrix. So we have successfully read two matrices A and B from the user. That is done. Is this okay to all of you up to this? Any doubt?
No, sir.
আচ্ছা, তাহলে আমি আরো প্রোগ্রেস করতে পারি। 3:51 বাজে আই উইল হেল্প। ঠিক আছে, আই উইল হেল্প। এরপরে কি ছিল? মাল্টিপ্লাইটা না করে আমরা একটা কাজ করি, লেটস অ্যাড টু দিস ম্যাট্রিসেস A plus B. Let's compute that matrix addition. ওকে, ম্যাট্রিক্স এডিশন খুব সোজা, সেজন্য অ্যাসাইনমেন্টে রাখা হয়নি, মাল্টিপ্লিকেশনটা রাখা হয়েছে। ওকে, নাও দেখো আমি একটা কথা বলেছিলাম যে আমরা যেহেতু ফাংশন শিখে গেছি, তো এরপর আমরা যাই কম্পিউটেশনাল টাস্ক করবো না কেন, দিস আর নট কম্পিউটেশনাল টাস্ক রিডিং অ্যান্ড ডিসপ্লেইং, দিস ইজ সামথিং ইনপুট অ্যান্ড দিস ইজ সামথিং আউটপুট টাস্ক, দিস ইনপুট টাস্ক। ফ্লো চার্টে দেখো, তাই না, এগুলো ইনপুট টাস্ক, দিস ইজ আউটপুট টাস্ক, নো কম্পিউটেশনাল টাস্ক ইজ দেয়ার। ফাংশন শিখে যাওয়ার পরে যাই ছোট হোক বড় হোক কম্পিউটেশনাল টাস্ক করবে না কেন, প্র্যাকটিস করবে ফাংশন ডিফাইন করে পাবে, ডেডিকেটেড ফাংশন ডিফাইন করবে, তার কাজ হবে ওই পার্টিকুলার কম্পিউটেশনাল টাস্কটাকে পারফর্ম করা। ঠিক আছে, কিন্তু অ্যাজ অফ নাও ফর সিম্পলিসিটি লেটস
হ্যালো স্যার, সরি টু ইন্টারাপ্ট স্যার বলছে কি ফাংশন ডিক্লারেশন অলওয়েজ নেসেসারি?
why we are studying function?
Sir, I am asking that we have to declare always function prototype.
That actually you know your answer of your own question. Why you are studying function at all? আমি তোমাকে পড়াচ্ছি 1D আরে 2D আরে, তাই বলে তুমি পড়বে সিলেবাসে আছে, বাট দেয়ার ইজ যেগুলো সিলেবাসে দিয়েছে কিসের জন্য দিয়েছে, তোমাদের কাজে লাগবে, কোনো ভালো জিনিসের জন্য কোনো ইম্পর্টেন্স আছে, দরকার আছে, রিকোয়ারমেন্ট আছে বলে না দিয়েছে। তো ফাংশন রাখার দরকার কি একটা সিলেবাসে? ফাংশন ছাড়া কি একটা প্রবলেম সলভ হবে না? এই কোর্সটা প্রোগ্রামিং ফর প্রবলেম সলভ, প্রোগ্রামিং তো শিখছোই, তার সঙ্গে তোমরা একটা প্রবলেম সলভ করবে। ফাংশন ছাড়া কি প্রবলেম সলভ করা যাবে না? করা যাবে। তাহলে ফাংশনটা শিখে আমার লাভটা কি, কি অ্যাডভান্টেজ কি, হোয়াট ইজ দ্য অ্যাডভান্টেজ?
স্যার যদি কিছু ক্যালকুলেশনে মিস্টেক থাকে তাহলে মডিউলে থাকবে স্যার।
হ্যাঁ, রাইট, দ্যাট ইজ module. So
Yes.
what we are doing, that is the modular programming. We may have
Yes,
a large program and we may have several bugs or several errors or whatever we may have to fix. Sometimes we need to update our program for কি বলতো, যখন ধরো আমার কিছু কোনো একটা পার্টিকুলার ক্ষেত্রে আমার প্রোগ্রাম রান করছে, স্যাটিসফাই করছে, আউটপুট আসছে, অন্য কোনো কিছু হলে আউটপুট আসছে না। ফর এক্সাম্পল ডেসিমাল টু বাইনারি কনভার্সন তোমরা করেইছো, ইন্টিজার ডেটার জন্য ইটস ওয়ার্কিং ভেরি ফাইন, বাট রিয়েল ভ্যালুর জন্য যেখানে ডেসিমাল পয়েন্ট রয়েছে সেটার জন্য কিন্তু অনেক সমস্যা হয়ে যাচ্ছে। ঠিক আছে, এরকম যত তুমি ইস্যুস তুমি কনসিডার করবে তত ইউ মে হ্যাভ টু চেঞ্জ ইউর প্রোগ্রাম, আপডেট ইউর প্রোগ্রাম ডে বাই ডে, রাইট। সো টু মেক ইট মোর জেনারেলাইজড, টু স্যাটিসফাই মোর নাম্বার অফ ডেটা সেটস, রাইট। ওটা করতে গেলে তোমাকে বারবার মেইন কোডিং এ হাত দিতে হচ্ছে, এবং তাতে কি হয়, ইট ইজ ভেরি ডিফিকাল্ট টু হ্যান্ডলিং লার্জ কোড। Then why we are doing? We are introducing the concept of functions. Functions are supposed to do dedicated tasks. For example, factorial. I mean, factorial journal, we do not want to write code over here. We just want to define a function just for factorial purpose. And I will just call it from the main function. I will not bother about to write a code to calculate factorial inside the main. Main will just call that function who is doing the factorial. That function is supposed to calculate factorial only. It will return the factorial value. That's it. So এটা করলে কি হচ্ছে, যদি আমার ফ্যাক্টোরিয়ালে কোনো ক্যালকুলেশনে যদি কোনো প্রবলেম হয়, আমাকে মেইন ফাংশনে হাত দিতে হচ্ছে না, আমাকে ওই ডিফাইন ফাংশনে হাত দিতে হচ্ছে। There must be some problem. So I don't have to touch the main function, which is a very large program. I just have to manipulate or change or fix the factorial based defined function only. This is called modularization. Function আমরা করছি modularization করার জন্য। ঠিক আছে, তো আমরা ফর সিম্পলিসিটি এখন আমরা কি করছি, যে মেইন ফাংশনের ভেতরেই কম্পিটিশনাল টাস্কগুলো করে ফেলছি। কিন্তু ইট ইজ আ বেস্ট প্র্যাকটিস, আই এম স্ট্রংলি সাজেস্টিং দ্যাট যখন ফাংশন হয়ে গেছে, whatever computational tasks, no matter it's a 1-line program or 10-line program, you try to do it with using function. কোনো computational task মেনে মনে থাকবে না, সব ফাংশন ডিফাইন করে করবে।
ওকে স্যার।
যদি না পারো সেটা আলাদা কথা, তখন মেনের মধ্যে করবে, কিন্তু বেস্ট প্র্যাকটিস হচ্ছে ফাংশন ডিফাইন করে করো, এইভাবে প্র্যাকটিস করা। বুঝা গেল?
ওকে স্যার।
হ্যাঁ, সো এটা গেল, কি যেন বলছিলাম, ম্যাট্রিক্স অ্যাডিশন, রাইট। ম্যাট্রিক্স অ্যাডিশন তার মানে ম্যাট্রিক্স অ্যাডিশন মানে a plus b. We want to compute this computation a plus b. Okay. So what is the logic to the matrix addition? What is the logic? In simple words, I want to compute. I want to so in matrix A is denoted by the syntax A I J. তাই তো নাকি? This is any arbitrary element Aij of a matrix capital A. Similarly, any element in B is denoted by the syntax Bij. Okay, so where Ij both lie in this range 0 to 2 for our example which we are taking. Okay, so how can I compute a plus b? So any element, let's say c equal to a plus b, let's say c equal to a plus b. So how to calculate any element in matrix C? Any element in matrix C will be denoted by this syntax Cij. So what is this? কে বলবে? কে বলবে?
Sir, Aij plus Bij.
Thank you, very good. So Aij plus Bij. That's it. This is a single line code or logic in which we can compute matrix. Okay, and this line should be done for all the values of I and j belonging to this, right? So element by element addition is giving you the overall matrix addition. So if you want to add this to matrix A plus B, first you add this element with this, you will get the element of 0, 0 location of capital C, correct? So you are actually adding element, corresponding element by element addition. Okay, addition of corresponding elements. So again you need a for loop, nested for loop. There it is. So capital C ij is equal to capital A I plus ij plus B I. Okay. So C I need to define it there. Everything I am defining, not making it that much generalized. Okay. CIT. Okay. And then display result. Resultant matrix. Result matrix. And just I need to change it C. Effortless matrix addition. Once I understand all the creation and all, the basic concept is how to access the elements, how to play with them, with the proper indices and the looping. That is the key. J, C are not declared. I get some declare for us. Oh, sorry. So first matrix 0, 1, then 2, then 1, then 2, then 3, then 2, then 3, then 4. First matrix. Second matrix is identity. 1, 0, 0, 0, 1, 0, right? 1, 0, 0, 0, 1, 0, 0, 0, 0, 0, 0, 1. Right, see. So this is the second matrix. Right? Display of the second matrix. And this is the result. Just cross check whether I am getting the desired result or not. Whether A plus B is done or not. Is it done?
Yes, sir.
Only the diagonal elements
Yes, sir.
will be added by 1. Rest will be unaffected. Am I correct or not? Because the non-diagonal elements are 0. Only the diagonal elements will be
Yes,
added with the diagonal elements of the matrix A. So they will be just changed by 1. Right? Other are same. So see how matrix addition is done effortlessly. Now similarly, matrix multiplication is you just tell me you can tell me now what is the logic of the matrix multiplication, and so that we can do that. So it is this is the one line logic to add two matrices. So similarly, what is the logic to multiply two matrices? So what do we have to change? This is fixed. You need to display the, okay, let me copy it. This is matrix addition. এবার তোমরাই করবে, এবার তো যেহেতু অ্যাসাইনমেন্ট আছে দেখো তো প্রোগ্রামটা সাজিয়ে দিলাম। This is, let's say, 2D the matrix multiplication. So everything is correct. A is done, B is done, A, B are read and displayed correctly. Here you need to change matrix multiply. Matrix multiplication, that is A star B. Okay? Multiplication operation is star. Here you need to change. দেখো তাহলে এই ব্লকটা আছে, এখানে কিছু তোমাকে করতে হবে, এরপরে তোমাকে যা লাগবে ঠিক আছে কোড। code here. Okay, and then it as it is Cij. So only thing you need to write over it. So anyone can tell me, just tell me the logic of matrix multiplication. Anyone?
So first we have to take input the number of rows and number of columns of first and second matrix. So then we have to check whether the number of columns of the first matrix is equals to the
No,
number of
ওগুলো সব আছে,
rows.
ওগুলো তো ধরে নিচ্ছি। Only just for this program, just make it run, make it implement this program only. A33, B33 are there, C33 is there. So you don't have to bother about it. I just want to focus on the main logic, multiplication logic. So you know, you have a matrix, any matrix A, and its element is given by, any element is accessed by A, I, comma, J. Right? Another matrix is there, B, of which any element is accessed by the syntax B, I, comma, J. এখন খুব সুন্দর চলছে। Okay, now you have this. Now what is the logic? How can you compute Cij? That is the logic. বলো।
So the first row of matrix A with the first column of matrix B.
Let me share the
The
program
elements.
to all of you. হোয়াটসঅ্যাপে দিয়ে দিলাম প্রোগ্রামগুলো, তোমরা দেখো, বলো। হ্যাঁ, এবার দাঁড়াও, স্ক্রিন শেয়ার। ম্যাট্রিক্সাইজেশনটা রান করতে গেলে তোমাদের মেশিনে ঠিকঠাক হচ্ছে না, জাস্ট ফিউ সেকেন্ডসে হয়ে যাবে। কোথায় গেলাম, বল বল। আচ্ছা, একটা ম্যাট্রিক্স এ আগে লিখে নিই, এটা যেটা ছিল, তো আর এটা ছিল এবার বলো। ম্যাট্রিক্স মাল্টিপ্লাই কিভাবে করো?
First row of matrix A with the
It is
first
something
column of
like,
matrix B.
so actually you are trying to find out this. Nine elements of matrix C, correct? Okay, so in doing so, what you are doing, so for this location, what is this? 0, 0, 0, 1, 0, 2, this is 1, 0। কেউ একজন বলো, তাহলে আমার তাহলে তাড়াতাড়ি হয়ে যাবে, না বলতে পারলে তাহলে চাপ। We are taking for this 0, 0 location, what we are doing, for 0, 0, we are taking 0th row, and here column 0, 1, 2. Okay, here I will select a particular row in first matrix, here I will take a particular column in the second matrix. That is the idea, first idea. But which row and which column, which row of first matrix A and which column of matrix B I will select, that depends on what is the location you are calculating for. Let's say 0, 0. First index is 0, means you have to select 0th row of matrix A. Second is index is 0, that means you have to select 0th column of second matrix B. That is the idea. So you are selecting this one and this one. Okay, and what you are doing, you are now doing element by element multiplication, means temporary I am writing over here 0 into 1, then 1 into 0, this one into this 0, then this 2 into this 0. Okay, so element by element multiplication we are doing. So how many such multiplications we are doing? 3 multiplications. Why 3 multiplications? What is changing over here? Here j becomes equal to 0. J become, okay, let me try with some other variable. Let's say k. So here k is equal to 0, k equal to 1. This 2 means k equal to 2. So this is 0, row index 0, column index k 0. Row index 0, column index k 1. Row index 0, column index row 2, column index k 2. Similarly, here it is column index, row index 0, row index 1. This is column row index 2. Okay, this is row index k equal to 0, but column index 0. Row index k equal to 1, column index equal to same 0. Row index k equal to 2, column index is still 0. So while doing this row index, let's say that is I, this is here I, and this column index, let's say that j equal to 0. So let me use I for row index of this matrix. Let me use j variable for as column index for matrix B, and let me use another variable k as column index of B, column index of A, or row index of B. Because that is same. You see, if I use k for this element, its index is 0. Also, here its index is 0. That means this element and this element have same index k equal to 0. So I can use same index for this element and this element. That's why I have used k only for here and here. Here k is the column index of this matrix, k is the row index of this matrix. So how many such k values are there? 0, 1, 2, 3. So there are 3 possible k values. Why? Because this is 3. Number of row columns, number of rows are equal. That is 3. And that gives you what are the possible values of k? 0, 1, and 2. And then what is this?
I.
Yes. Absolutely correct. And what is this 3?
J.
Yes. Again, absolutely correct. So you got to know that we are about to generalize the program of matrix multiplication in terms of I and j and k. So I is coming from the number of rows of matrix A. J is coming from number of columns in the matrix B. And the common dimension, that is the number of columns in matrix A, which is equal to number of rows in the second matrix. For that purpose, I can use another third variable k. Okay? Okay.
Yes, sir.
So let me compute all these sums, multiplications. What you have to do? So, okay, now coming to this one. How can you calculate this element, 1, 2? For that purpose, you have to select row 1 and you have to select column 2.
A of 1, 2 into
Yeah.
B of
So what we are picking, actually we are picking any element in this row is specified by the row index I and the column index k. Any element here with any element in this column. So how to get any access to any element in this column? So row index,
K.
here will put the row index, here will put the column index. What is the column index? That is
J.
What is the row index? We have
K.
used k, that is. So this is representing any element of a selected row here. This represents any element in the selected column of the second matrix. And we are multiplying them. How many such multiplications you are doing? The number of k, how many are there? 3. So then what you have to do? You have to sum them up, add. So all these terms you need to sum for all the values of k equal to 0 to 2. What you will get? You will get a single value of this, such a value. From this formula, you will get a single value. And here, you need to finally repeat this for all the values of j in this range 0 to 2. So entire this line should be inside this already designed for loop. So already for loop is designed, this one. So this line I will change now. What will be there? It will be aik. And here it is simply why you are doing. There is so many understanding behind this. Okay, this is the multiplication logic. But by this line I am getting here it is plus, so it should be star. So you have to collect repeatedly, multiply it. দেখো আমরা শুধু এই পোরশনটা শুধু লিখেছি aik into bkj, সামেশনটা কোথায় গেল কে বলবে? কেউ একজন আমি আর কিছু বলবো না, ঠিক আছে? আমি এই কোডটা শেয়ার করে দিয়েছি অলরেডি, আমি আরেকবার শেয়ার করে দিচ্ছি। তোমরা এই জায়গাটা চেঞ্জ করে কি করবে সেটাকে করে আউটপুটটা এবার দেখাতে শুরু করো। এবার বাকিটা তোমাদের বুদ্ধির উপর অ্যাসেসমেন্ট করতে হবে। তাই ওকে, any query you can ask, any query. I think we should stop. Any query here? No query. Then stop recording.